Hello AP Stats students, this is Mr. Hazelhorst with your Chapter 11 video. What we're going to talk about today are just the basics behind the idea of a significance test. And so this will kind of be a big picture idea. We'll get into a little bit of the details, but if you kind of walk away from today's video, not clear on some understanding of some things, as we get into example problems over the next week and throughout Chapter 11, hopefully we can clear up a bunch of those issues. But again, as always, when you get to the end of the video, if there's anything that you want to make sure that I really hit on in class, please make comment of that just in that comment section on the form. But let's get started. So we want to start today the same way that we started Chapter 10. When we talk about statistical inference, again, we want to keep in mind that the big idea behind this is that we're trying to draw conclusions about a population from sample data. And that's going to continue to be our focus not only here in Chapter 11, but throughout the rest of the chapters that we deal with here in AP Stats as well. So again, there's two big types that we're going to focus in on. We just finished up with confidence intervals in Chapter 10, and now we're going to move into this concept of significance tests in Chapter 11. And hopefully a lot of the details you're going to recognize from the work that we've already done in Chapter 10, because again, both of these are based on the concept of sampling distributions in Chapter 10. So keep that in mind as we move forward. And again, you're going to see a lot of repeat towards steps in the process and so on, but there'll be a few new things as well. So let's start out with a formal definition of significance testing. Again, as always, just like confidence intervals and this whole idea of statistical inference, our goal here is we're going to take observed data from a sample and we're going to compare it to a hypothesis. And the goal of all of this will be to see if we can assess some truth about the population. So as you look at the goal down here, it says our goal is to assess the evidence provided by data about some claim concerning a population. Okay? So again, it's impossible for us to study an entire population, but we can draw some truths about it by working with sample data from that population, and that's going to be what we continue to do today. An important thought to keep in mind, what we're really looking for when we talk about the evidence that I mentioned in the goal, all right? The evidence is probability, all right? And so when we think about this important thought down at the bottom slide here, it says an outcome that would rarely happen if a claim were true is good evidence that the claim is probably not true, all right? So what do we mean by that? Well, I want you to think about a normal distribution, okay? And if a claim is true, we're going to assume that that's true, and so we're going to assume that that sits in the center of our distribution. So I want you to think about, all right, where would things that would rarely happen occur as we look at a normal distribution? Well, ultimately, what we're going to look for is we're going to try and find data that falls out in one of the two tails, or maybe both tails, because those are the areas where things rarely happen, all right? And if we just take one sample and we happen to find something that's a long ways from what we are assuming is true, well, that's going to be our evidence that there's something that's probably not true, all right? Now, I know, again, this may not be clicking real well, so let's try and give you an example here real quick. So let me talk a little bit about myself. I have a skill that I'm pretty proud of, and this might surprise you a little bit, but believe it or not, I am actually pretty close to a 90% free throw shooter from the foul line. So if you put me on a basketball court and we shoot free throws, I can knock down free throws all day, all right? Now, I know right now you're probably thinking, Mr. H, we've seen your ability as a math teacher. We highly doubt your ability as a free throw shooter. And so, you know what I'd say? All right, well, it's true. I am a 90% free throw shooter. And what in your thought is going through your mind right now? My guess is you might be thinking something along the lines of, I'd like to see this. Let's prove that. So let's say we did that. We went down to the gym, and I started to shoot free throws, all right? So I step to the line, take a couple dribbles, put the first shot and up and in and swish, right? And would me just taking one shot be enough to verify, and making that one shot be enough to verify in your mind that I am a 90% free throw shooter? Now, hopefully as students of statistics, you'd realize, no, we need a larger sample size than just one shot. So we stay down in the gym for a while, and I continue to shoot free throws, and maybe I'm shooting pretty well early on. But then after a while, let's say I hit a cold streak and I just start clanking them off the rim. And when I get done, let's say that I've taken 50 shots and I only made 25 of them. Well, if I claim to be a 90% free throw shooter, and you collect some data, and that data that you collect shows that I only made 25 out of 50 shots, what are you thinking about my claim of being a 90% free throw shooter right now? My guess is you highly doubt that's true. Now let's think about this from a statistics standpoint. If I really am a 90% free throw shooter, is it possible that out of 50 free throws, I may only make 25 out of 50? Well, in your mind, you're probably thinking, yeah, it's possible, but if you're a 90% free throw shooter, you know that shouldn't happen very often, right? We would say the probability of that occurring would be pretty low, and you'd be right. And that fact, that the probability of me being only making 25 out of 50 free throws being a pretty low probability, that's what causes you to doubt my claim of being a 90% free throw shooter. And when we talk about significance tests and testing a hypothesis, that's what we're going to look for. Is the sample data that we collect close to the hypothesis, because that's what we'd expect to happen? Or is it far away? And that would be what we don't expect to happen. And if it does, that's going to lead us to doubt the truth of the claim about a population. So that's just kind of a little example that I want you to keep in mind as we go throughout not only this lesson, but throughout all of chapter 11 as well. So what I want to talk to you about next is the process of a significance test. All right, what does it look like from beginning to end? And this is our inference toolbox. And you're going to notice that we're going to follow the exact same steps that we followed in chapter 10. Our first step, again, is going to be that we're going to deal with the parameters. All right, we're going to state our parameter of interest. We're going to define it in context. But we're also going to add something new today, and we're going to talk about this. That's why it's highlighted in yellow here. But we're also going to add in the idea of a hypothesis. All right, we're going to deal with a null hypothesis and an alternative hypothesis, and I'll get into more detail in these here soon. All right, then our second step will be conditions. Now, what I want you to notice is that we're still going to deal with the exact same conditions that we dealt with in chapter 10, and nothing's going to change there. And so hopefully this is something that we're getting pretty good at. We need to see a simple random sample. We need our distribution to be normal, and that condition for normality is going to depend on whether we're dealing with a mean or a proportion. And then again, we need to be able to show independence. Okay? And then our third step, again, is calculations. And our calculations, obviously, we're not calculating a confidence interval, so we're going to have some different values there. And what we're going to talk about today is the idea of a test statistic and what we call a p-value. Okay? And these are pretty simple concepts, and I think you'll grasp these relatively easy. But this is going to be what we use to help make our decision. And then our fourth and final step is going to be that we need to make an interpretation of our significance test. And ultimately what we're going to get down to is, are we going to reject or not reject the truth or the claim that was made about in our null hypothesis? All right? So to kind of paraphrase Shakespeare here, we'd say to reject or not reject, that is the question. And we'll get into the details of how to make that decision later on in the chapter. Again, what we want to focus on the rest of today's video is the idea of writing hypothesis, and then the test statistic and the p-value. And if we can have a somewhat clear understanding on those through today's video, I'm going to be pretty happy with that outcome. All right, well, let's get into the hypothesis. So as we write our hypothesis for a significance test, and again, this is going to fall underneath the parameter step, we're going to have two hypotheses that we're going to write. The first is what's known as the null hypothesis, and we're going to abbreviate that as H sub O, as you can see right here. Okay? And what the null hypothesis is representing is the claim, or what we're going to assume to start, is a truth about the population. And this will always be a statement of equality relating to a parameter. So the example that I'm giving here, this would be an example of how we would write the null hypothesis for my free throw shooting example that I talked about earlier. I claim to be a 90% free throw shooter, right? Well, 90% is a proportion. So I'm writing a statement of equality relating to P, our population proportion. So again, we would go into that assuming that I really am a 90% free throw shooter, and our goal would be to find evidence against that claim. All right? So when we talk about the null hypothesis, again, that's the claim or truth that we're going to assume about a population. The alternative hypothesis, which we're going to represent with H sub A, this is going to express our suspicions about the population parameter. And we need to write these before we see data, all right? We can't look at data and then write an alternative hypothesis because, well, then obviously we have a little bit of bias, okay? So when we, again, use the example of me as a free throw shooter, you know, your claim, my guess is as soon as I said I'm a 90% free throw shooter, your thoughts were, yeah, right. And it wasn't, yeah, right, you're a better free throw shooter than that. My guess is it was, yeah, right, you're worse than that. So in your mind, the alternative hypothesis would be that my proportion of free throw shooting is less than 90%, all right? And so again, that would represent your suspicions, and that would be what you're trying to find evidence to support. You're trying to disprove my claim of being a 90% free throw shooter and show that no, Mr. H, we really don't think that is the case, all right? And so the null hypothesis, again, is going to be a statement of equality. The alternative hypothesis will be a statement of inequality, all right? And there's three symbols that we can use here, and that'll kind of break down our alternative hypothesis here a little bit more. So let's talk just a little bit more about the alternative hypothesis. So because the alternative hypothesis is going to be a statement of inequality, there's actually two types that we can deal with, all right? We can deal with a one-sided alternative hypothesis, and this is where we're interested in a change from the null that's in a specific direction. So we're either going to use the greater than or the less than symbol. And again, that's going to specify one side of the distribution. All right? The other type of alternative hypothesis that we can deal with is what's known as a two-sided alternative hypothesis. And so this is where we don't think the null hypothesis is true, but we're really not sure if it's larger or smaller. And so we call this a two-sided alternative hypothesis, and we just use the inequality symbol of not equal to. All right? So if a direction is specified, we'll use greater than or less than. If it's not specified, we'll just say not equal to. Okay? And this will change how we work the process of a significance test, but we'll get into those details with some examples later on in the chapter, so we don't need to stress over that too much right now. All right? So what I want to do next then is just look at a couple of examples of hypothesis writing. So I'll give you an example, and we're going to write some hypotheses here. So here's our first example. All right? Let's say Larry's car averages 26 miles per gallon on the highway. He switches to a new brand of motor oil that is advertised to increase gas mileage. After driving 3,000 highway miles with the new oil, he wants to determine if the average gas mileage has increased. All right? So first thing we need to determine in this problem is, are we dealing with a mean or a proportion? Because we need to represent the appropriate parameter within our null and alternative hypothesis. And in this case, obviously, we're dealing with an average. Okay? So as we see that word in there, we know we're going to deal with a mean. So we're going to want to use the symbol mu as we write our null and alternative hypothesis. So let's start out with the null hypothesis. Okay? What are we going to have to assume is true? What's the claim in this problem? Okay? What we have to assume is true is that Larry's car is going to continue to average 26 miles per gallon. Again, the null hypothesis is always a statement of equality. So we're going to just simply assume that mu is equal to 26 miles per gallon. All right? That's going to be, again, what we assume about the population. All right? The alternative hypothesis is going to be what we suspect, or in this case, what Larry is hoping happens. All right? And in this case, since we're given a specified direction, he wants to see that his gas mileage has increased. We know we're going to be dealing with a one-sided alternative hypothesis. All right? So we want our mu to be greater than 26 miles per gallon. And these would be the hypotheses that we are then going to work with throughout this problem if we're going to continue on and do the entire four-step process. Okay? But again, that's the idea of writing a hypothesis. Hopefully you see that's pretty simple. Again, we just take the value, we write a statement of equality for our null hypothesis, and then we write a statement of inequality for our alternative hypothesis. So let's try another one of those. So at this point, I want you to actually pause the video, read through this example problem, and just on a piece of scratch paper, just jot down what you think the null and alternative hypotheses would look like for this problem. And then when you get done, push play, and I'll go through what it actually looks like. But I want to give you a chance to practice this beforehand. Okay? So, again, pause the video. I'm serious. Pause the video. All right, well, hopefully you wrote some hypotheses. And so let's go through this problem and see what they should look like. All right? Well, again, the first thing we need to determine, are we dealing with a proportion or are we dealing with a mean in this problem? And here we're dealing with a proportion. We've got a percent from a Gallup poll. So we're going to write both our null and alternative hypothesis in terms of P. Okay? So what we're going to have to assume, that our school's population just follows the national average. So we're going to say that P is equal to 0.72. Again, statement of equality will always take place in our null hypothesis. The alternative then, we need to, again, write a statement of inequality. Now, as you read through this problem, nowhere does it specify a direction. It doesn't say that you think the national result is going to be lower than your schools or higher than your schools. And so because direction is not specified, our alternative hypothesis will be that P is not equal to 0.72. And so that's what hopefully you wrote down on your sheet of paper. And if so, great job. If not, that's all right. We'll get more practice with these down the road. All right? But now let's jump into the concept of the test statistic. So when we talk about a test statistic, what I ultimately want you to think of is it's a z-score. And when we think about z-scores, hopefully you think about a z-score as a position along the normal distribution, right? So if I give you a normal distribution, right, we can assume in the middle that it's 0. And then if I give you some z value, right, if I say, okay, z is equal to 2.37, right? Well, hopefully you know enough about z-scores to say, okay, well, z, you're going to be more than 2 standard deviations away from the mean, so you're going to be out here a little bit, but you're going to be about right here on our normal curve, okay? So as we think test statistic, that's what I want you to think. It's a position on the normal distribution. Now, the formula for the test statistic is given to you in your gold packet, and it's given in general, all right? And this is the statement that you're going to see in your gold packet. The standardized test statistic is going to be equal to our statistic minus our parameter divided by the standard deviation of the statistic. And remember, the standard deviation of the statistic, those formulas are given in the table right below this formula, okay? So here's what the test statistic will look like for the mean, okay? So again, thinking of a z-score, we take our statistic, which for a mean is x bar, minus our parameter, which is mu, divided by sigma over the square root of n, all right? For a proportion, our statistic is p hat. Our parameter is p. Standard deviation is p times 1 minus p over n, the square root of that quantity. All right? So these are what the test statistics will look like specific to a mean and proportion. But again, notice they follow the exact same parameter. Statistic minus parameter, statistic minus parameter divided by the standard deviation of that statistic. All right? So what in the heck do we do with a test statistic then? Well, again, the test statistic is just simply a position on the normal distribution. And what we ultimately use that position to do is find a p-value. So let's take a look at the p-value. So the p-value is simply going to be the probability, assuming that our null hypothesis is true, that our sample data would take on a value as extreme or more extreme than the value we actually found. Okay, so let's use this picture to kind of illustrate this concept, all right? So if we are assuming that our null hypothesis is true, well, we're going to put that null hypothesis right in the middle, right? That's where we're going to put the truth that we're assuming. So then we calculate this sample data, we run and find our test statistic, right? And z, right, our test statistic is telling us how far our sample value is from that assumed truth, that null hypothesis, right? So this would be where our sample data would fall, right? Wherever z would put us at. And then what the p-value is going to represent is the probability that we would get something that extreme or more extreme. So we're always going to be shaded into the tail region, all right? So our p-value is just the area under our curve beyond our z-score. And what we're going to be looking for ultimately is low p-values. We want to find small probabilities, right? The smaller the p-value, the stronger the evidence we have against the null hypothesis. Because again, think about this statistically. If the null hypothesis is true and we're collecting data, we expect most of the data, right? 95% of the data should fall within 2 standard deviations of the mean. And so when we start to get those lower p-values, that's when we start to doubt the truth of the null hypothesis. And so that's what we want to keep in mind, all right? Now, a couple years ago, I had a student who came up with kind of a clever little way to remember this whole idea of low p-value, all right? But he said, if the p is low, reject the ho, all right? Ho being the null hypothesis. So again, we're looking for small probabilities. Small probabilities is strong evidence against our null hypothesis. And we'll talk about how to deal with that here as we go through example problems in the rest of Chapter 11. All right? So in closing today's video, what I really hope you can take away from it is, one, you have a solid understanding of how to write a null and an alternative hypothesis just from a problem. We looked at a couple of examples of that. I hope you have a basic idea of what the test statistic is representing. Again, it's representing a position on a normal distribution. And then finally, we hope you have a simple understanding of the p-value, which again, that p-value is going to represent the probability that we're going to use as our evidence against a null hypothesis. All right, so if you have a basic understanding of those 3 things, you've taken from this video what I hoped you would. Okay. As always, I'm going to ask that you fill out the form below the video. If there's any concepts or things that you're still a little fuzzy on, please make comment on that in the comments box so that I can use that information to help guide our lessons here next week. And hope you guys are enjoying your 4-day weekend, and we'll see you on Tuesday. Have a great day. Bye.
Made with Doodlecast Pro.